Hey class, a question was raised about one of the math lab questions, and so I'll just read it to you guys based on what the questioner is asking. Okay, so there's a container that contains 6 diesel engines. Okay, so there's 6 diesel engines, and let's see, a company chooses 4 engines at random. Okay, so they're choosing 4 engines at random. But they will not ship a container if any of the engines are defective. Okay? So engines defective means there's no shipping. Okay? So the question is, what's the probability that a container will ship even if it has 2 defects and the sample size is 4? Okay? So you can kind of think of this question more in terms of the concepts as opposed to the probabilities. Okay, you can tell that this has to do something with combinations or permutations or maybe binomial. Who actually knows? But if we think it through, if we think about what's going on here, we should be able to derive the answer. Okay, so let's look at what exactly we're looking at so far. So here are my engines, okay? Not much of an engine, but I have 6 engines, okay? So the first thing you have to realize is that we're going to choose 4 at random. So since it's random, it's possible that I could choose 1, 2, 3, or 4, or maybe 1, 2, 4, and 5, or 2, 3, 4, 5. So any of these is actually choosing 4 at random. So the question becomes, how do I actually justify how many possible combinations of choosing 4 out of 6 there are? And I kind of gave you the answer. The answer is by using a combination. So remember, a combination is NCK. You may also see it written like this, okay, NK. And the N represents the overall number. So in this case, we have 6, right? And the K represents how many you select. And we're selecting 4. So of all possible ways to choose 4 out of a group of 6, there are 6 choose 4 of them. Let's keep that in mind when we look at the next sentence. So now we know how many engines we have, but we don't know anything about these defects. Let's take a closer look at the defect part. So far, we have selected a sample of 4. Okay, so let's say these are our 4 engines. Okay. Now, the key sentence here is that the container will not ship if we have any defects at all. Okay? So that means that not only is this engine supposed to be okay, so will this one, so will this one, so will this one. How many ways can we actually find 4 total with no defects? Okay? It's pretty clear because we're looking at no defects, but there's actually a way we can calculate this too. And this is the same combination formula, NCK. So now we have 4 of the engines, and the question is how many defects are we allowed to have? And here we want to select 0 of the engines that have defects. Okay? So remember, we have 6 total. We have 6 total. These 4 we choose, but that means there are 2 that we did not choose. Okay? So if the container has 2 defects and we've chosen 4 that have no defects, that means the other 2 here both must be defective. Okay? So when we look at this part, it's again a combination, NCK. But the question is, how many are we looking at total? We're looking at 2. And how many defects are there from the 2 that we don't choose? All of them, or both of them. So 2 choose 2. So now when we put it all together, you'll notice that we have what's called a hypergeometric function. Okay, it kind of looks like the binomial, but it kind of has some combinations in there as well. I won't bore you with the actual formula for it, but I will just plug it in so you can see how it works. Okay, so let's go back to the beginning and look at what we have. So in total, at the bottom, think about the fact that we had 6 containers and we selected 4. Okay, so that's our denominator for this probability. Okay, but out of those 4 we selected, we need to ensure that we do not select any with any defect, which basically means the 2 that we did not choose must be defective. Okay? And from here, we just basically simplify and find out how much we get. So remember how you calculate a combination, right? So n choose k equals n factorial k factorial over n minus k factorial. So keep that in mind, and you'll see where it comes from in a minute. Okay? So let's look at that first term. 4 choose 0. 4 choose 0 means 4 factorial, 0 factorial times 4 minus 0 factorial, which is 4 factorial. We can see pretty simply that 4 factorial and 4 factorial cancel out. And you just have to trust me here that 0 factorial also equals 1. So 4 choose 0 equals 1, which makes sense. There's only one way to select no defects from a group of 4, and that is if none of the engines have defects. Okay? So there's only one way you can have that happen. Now the 2 choose 2. Okay? That means the 2 engines that have defects, those are the 2 that you want to have as defective. So again, we have 2 factorial, 2 factorial, 2 minus 2 factorial, which is a 0 factorial again. And you'll notice again, 2 factorial and 2 factorial cancel out, which gives us a 1. So for the numerator, we have 1 times 1. Okay? But the denominator is where we actually have some calculation to do. 6 choose 4. Right? So the numerator, the top number is 6 factorial. K is 4 factorial times 6 minus 4 factorial, which is 2 factorial. So for shorthand, I'm going to expand the 6 factorial, but only until I get to 4 factorial, because they're only multiplying another 5 and a 6. Right? So for 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1. Well, 4 times 3 times 2 times 1 is the same as 4 factorial. Okay? That's the numerator. The denominator, 4 factorial, is in fact 4 factorial. And 2 factorial is 2 times 1, which is 2. Okay? So, we look at it again. 4 factorial cancels with 4 factorial. The 2 and the 6 cancel, which gives you a 3. 3 times 5 is 15. So if you look at what your equation is, you take, I'll just draw a line here. 4 choose 0, 2 choose 2, over 6 choose 4, which is 1 times 1 over 15, which is 115, which is 0.067. And that's the answer you see in your textbook. So hopefully this little small video helps you understand where they get the 0.067 from. But if not, feel free to shoot me another message and let me know. Thanks. Take care.